So once you have your data in R, you're going to want to explore it. And we're going to use a tidyverse package called dplyr that provides the most useful functions in R. When I say most useful, I mean when I go and look at my code for projects I'm working on, 60 to 80% of it is these 5 verbs, plus maybe group by and using ggplot, which we'll cover later in the week. So we're going to talk about select, arrange, mutate, filter, and summarize. These are 5 verbs you should memorize. So select is used to pull columns from your data. So here we have a storms data set. We only want to know the storm name and pressure, so we select storm and pressure. Let's try out select. So we write select, open parentheses, and in the first position, we're going to put our data. The first position always has data with these dplyr verbs. Then we pick the columns we want. So for example, when we run it, the data is spit into the console with the columns that we selected. I just want to point out a few things. One, this is not stored with a name. If we want to reference it later, we got to use the arrow and give it a new name. Now, what if I want to do the opposite? I want to get rid of some columns. There's a shorthand for that, which is this minus sign. So if I run this, I got rid of the year and month columns. To save yourself some time, if you have a lot of columns you're trying to get rid of, you can say minus and then put a vector. What happens when we have a typo? So let's say I want the city and the listings, but I missed the S. I get this error down here. The column listing doesn't exist. When you get an error like this, the first thing you got to do is check for a typo. So I can say, what are the names of my columns again? Put in names, Texas housing data, and then I see, the column should be listings. I missed an S. You fix that, you're going to be good. Now, select comes with a lot of helpers, which I've opened the documentation over here. I'm going to show you one of them. Let's say you want to change the order of the columns. You want city, date, and then everything else. Instead of typing everything, you can type everything. And here we get the columns reordered. That's select. Arrange helps you sort rows. So here we want to see the data arranged by wind speed. So we arrange it from the smallest wind speed to the highest wind speed. It's easy to order data with arrange. Type arrange, and then in the first position, you put your data. Then you pick a column you want to have arranged. So here we see volume in increasing order. What if we want to have it in descending order? Then wrap volume in desk. This gives us the data frame in descending order based on the volume of sales. We see Houston in 2015 had the highest volume of sales. We can also arrange by multiple columns. So let's say I want to have years in descending order, so I'll start with 2015 and then look at volume. So we have the data with the year going from 2015 down and the volume going from the smallest volume within the year up. If you want to explore this yourself, I recommend bringing this into your own org and then putting it into view. So if we scroll down to the end of 2015, we see the volumes are increasing until we get some missing values. And then we start over in 2014. The missing values will always be at the bottom of your sort. Now I'm going to introduce the pipe operator. The pipe operator takes stuff from the left-hand side and it makes it input on the right-hand side. So these two functions here are doing the same thing, the select calls. In the first one, it's written as we're used to so far. We have select, and then in the first position we have data, and then a bunch of columns. The second way we write it here might be a little more intuitive. We take Texas housing data and then select from it these columns. Notice how I read this, and then. We take Texas housing data and then select. This pipe takes Texas housing data and it puts it in the first position. And notice how I've stressed that the first position for dplyr verbs is always data. So the output of the dplyr verb is also data. So we can pipe together a string of commands. For example, here I take Texas housing data and then select my columns and then arrange it with the median descending. So we see the 4 columns I asked for and the median house price from highest to lowest. Mutate is one of the most awesome dplyr verbs. It lets you take columns of data and create new columns. So I might not care about wind and pressure by themselves, but rather I'm interested in their ratio. So I can calculate the ratio of pressure over wind, and I get a new column. So let's see how mutate works. I'm going to make use of the pipe by starting with the data, and then I'm going to select some columns, and then I'm going to mutate. I'm going to divide volume by sales. That'll give me an average price of houses sold in a city, year, month combo. So to do that, I just say I need to come up with a name. That's one of the hardest parts. I'll call it mean price. And then calculate it. That's volume divided by sales. So we see in the console here, a new column has been created called mean price, which is volume divided by sales. Now I just kind of added a new feature to R without telling you about it, and that's that R is a calculator. Any kind of math you can think of, R can do. So the easy stuff is, it can add, it can subtract, multiply. We just saw divide. We can raise things to powers using the caret. We got 4 squared. We have a log. We have square roots. There's sine functions. Pi is built in. The number e isn't built in, but we have exp, which is e to a power. So if I do e to the first power, I get e. If I want to do log in base 10, that's built in. So it has a full set of mathematical tools. We're going to make use of that when we mutate. So let's mutate a few more columns. Let's say we want the log of volume. We'll do log volume. We can even manipulate columns we just made. So for example, if we want the square root of the mean price, we can take the square root of the mean price. Let's see how it works. So we got mean price, the square root of the mean price, and the log of volume. Filtering lets us pull out rows or observations by some match criteria. So in this case, I'm not sure what they picked. Maybe they've said they want storms named Alberto and Ana, and that's what they have here. But filter gives you a lot more power to pick out the data exactly as you want it. Let's try filter out. I'm going to start with Texas housing data and then select some columns and then mutate some columns and then filter. Filter, like other dplyr verbs, takes data in the first spot. So when we do this piping, the result of the select and mutate will be a data frame that goes in the first spot of filter. Then we put some match criteria. So for example, if I only want data from 2013, I can say year equals 2013. When I run it, I see I have many fewer rows than before. So these match criteria require us to learn some new R tricks. To determine our match, we use relational operators. Relational operators return true or false, and they test a relation. So for example, we can use greater than or less than. We could say, is it equal to something? Or is it not equal to something? Or does it match something in a group? So here's an example of each of those operations. So here we have the operators in practice. If we ask if 4 is less than 4, the answer is false. If 4 is greater than 4, it's true. Does 4 equal 4? And again, we're using two equal signs. True. Is 4 not equal to 4? False. Is 4 in the vector 1, 2, 3? False. The relational operators always return true or false or NA. We combine relational operators with logical operators. I'm going to discuss these in much more detail when we talk about if statements. But for now, let's just get this into our head. We use exclamation point for not, we use the ampersand for and we use the straight line for or. In logic, not means the opposite. So not true is false. And means we need both things to be true. And returns true when both operands are true. So here we have true and false. Something's false, so we get false. Logical or is the opposite. All we need is one thing to be true and the whole statement is true. So if we have true or false, the result is true. Okay, now how do we combine this with relational operators? First, we evaluate the relational operator, and that's going to give us true or false. Then we go through the logic, and you see some examples here. Now, this is one of the harder things to wrap your head around, so we're going to have plenty of time for practicing later on. Now that we've built up our understanding of relational and logical operators, let's combine those to make a more complicated match for our filter. So before we had year equals 2013. In the filter, using a comma is the same as saying and. Let's see data from 2013 in Houston. So here's our result. We have 12 rows, one for each month, and that's that. Now let's say we want to pick Houston or Austin. Now here, if we put a comma, we're going to be in trouble. Let's see. I get a table with 0 rows. Why? It's because this comma is treated as an and. None of our rows have data from Houston and Austin. What we need is an or, and we can use the vertical line. So now we have 26 rows with Austin and Houston in 2013. If we want to add more cities, using these ors is going to get kind of old. So we can use the in operator. So let's say we want data in Houston, Austin, or Dallas. So here I have a vector with Houston, Dallas, and Austin. And I say if the city matches any of these, if the city is in this group, then let's take it. So we can't see all the cities here. We can throw this into view and we'll see that we got the right results. Alternatively, let's just arrange by what will give us the thing we want. Let's arrange by month. All right, so here we have Austin, Dallas, Houston, Austin, Dallas, Houston. We only have those 3 cities. Perfect. Finally, we can summarize data with summarize. Summarize takes a column and it can crash it down to the median. It can add up all the values. It can take the first one, the standard deviation. Let's see how summarize works. Here I took Texas housing data, I selected some columns, and then filtered the data. So right now, we have Houston data from 2013. Let's say we want to know the total volume from Houston in 2013. Then we say summarize. In the first position goes data, which the piping will give us. And then we can write some commands similar to mutate. So I want the total volume, which is adding up all the volume, and there's a function for that, which is sum. So when I run it, I get a tibble that is one row by one column with the total volume, which is a very large number. There are a lot of helpful functions that might be useful to summarize. So here in the documentation, there's a list of useful functions. For example, finding the center of the data, the spread of the data, the range, counts. So for example, if I want to know the number of months, I can say n. And let's add the standard deviation of volume. So like mutate, I can put in several different summary statistics that I want, and I will get them into a table where the column names are based on what I put on the left-hand side here, and the values are the result of these functions. Now, you might get a common error if you try and do something that doesn't return a single value. So for example, let's say I do the mean volume, or what did I call it? Mean price, where I do volume divided by sales. Now we know from last time, volume divided by sales gives us one result for each row. If I run it, I get this error. Column mean price must be length 1, not 12. So that tells me that this math returns 12 values.
With that, you've seen the 5 dplyr verbs of highest importance. Commit them to memory. When you add GroupBy to them, you're going to be able to do so much data analysis. On top of that, we covered how to use relational, binary, and logical operators. We're also going to use these over and over again. So in all, this was a lesson with a lot of fundamental concepts.